and welcome to a new video. In this video, I'll be discussing about my Sudoku solver code using Python with the backtracking algorithm. Now, before you start this video, make sure to check out the previous video in which I've discussed about the backtracking algorithm, how it works and what is it all about. Okay, so that is pretty much extensively used in this video. So if you haven't checked out the previous video, please pause this and check out the earlier video. All right, I'll insert the card above so it'll be easier to navigate. All right, so in this video I'll show how I've written my code. So first of all, in my code, in my program, I am defining my board as in Sudoku board, as a 9x9 2D array. All right, so I've written in Python. So using this like notation and syntax, you can define this 2D board. Now an important point to note is that zeros in this board, that is, you can see here where my cursor is, zeros are basically just notations for empty cells on your Sudoku. All right, so wherever you see a zero, that means there is an empty cell. Okay, so this is my Sudoku. I've written in this format and the user has to input this in order for the program to work. Okay, so next up, I am defining my first function, that is print Sudoku, and it takes the input as your Sudoku board. So basically what I'm doing is, for I in range of length of board. Now this, if you see my window, this thing is length of board, all right, which is equal to 9, and this thing, your length of first column, that is length of board 0, that is your length of first row, which is also equal to 9. So what I'm doing is I'm looping for I in my range of length of board, that is I goes from 0 to 8. If I modulus 3 equal to 0 and I not equal to 0, just print like this dashes, hyphens, a series of hyphens that just denotes a division of your Sudoku board. So say you've got entries like this. Okay, sorry, let's use asterisks. You've got some entries like this. All right, say you've got entries like this. Now normally in a Sudoku board, when you encounter 3 rows, you see that it's separated by a line, right? And similarly lines on the vertical side as well, denoted in this sample Sudoku by your red lines. So these hyphens, series of hyphens, is basically just my partition. Okay, so what I modulo 3 equal to means, if I is divisible by 3, print a series of hyphens. All right, and I should not be equal to 0. Basically that's what this line is doing. Now next up, for j in range of length of board of 0, basically that means you're looping j through your first row, like length of first row that goes from 0 to 8. If j modulo 3 equal to 0 and j not equal to 0, you just print a pipeline, vertical line. So basically this thing is basically my pipe. That's what this particular line of code is doing. And end equal to quotes. All right, that's the syntax. And if j equal to 8, that means if you reach the last column of any row, then you just print your value, board value, the value of that particular place. And if this is done, else, so if j is not equal to 8, just print your board value, whatever it is, plus end. Okay, that's how it works. So that's my print function. Now next up, what I'm going to do is, whenever you solve a Sudoku, what's the first thing you do? You first of all find an empty cell, right? You find an empty cell. All right, so this function, find empty cell, precisely does that. So what it does, it takes your Sudoku board as your input. Now it loops through each and every element of your Sudoku board. So for I in range of length of board, that is I goes from 0 to 8, and for j in range of length of first row, that means j goes from 0 to 8. So basically you're nesting your for loops, and if board of ij is equal to 0, As I mentioned earlier in my code, 0 implies a empty space. So if you encounter a 0, that means there is an empty space. So what do? Return I comma j. Now usually in syntaxes what we do is I corresponds to your row and j corresponds to your column, right? But in this case I is in range of length of board, so that means that I is going down like here and we are looping j like this. So basically in this case I is equal to column and j is equal to row value. So we're returning in the form of y comma x. So y comma x coordinate of your empty cell. Okay, this find empty cell basically returns the position of your empty cell. All right, next up we have the function valid Sudoku. So what it does is, given this function, it takes my Sudoku board as my first parameter, my number, that is which the number to be inserted in that empty cell, in a particular empty cell at a specific position. So you take your parameters are board, number and position. So these are the parameters that this function valid Sudoku takes in. So what it does, so for the uninitiated, a Sudoku is valid if and only if there is only one value in a row, column and this small box. All right, so just for example's sake, if 1 is present here, then that means that 1 cannot be present in the first row in any cell, 1 cannot be present in the first column of in any cell, and 1 cannot be present in this small box. So this small box, okay, the first small box. So that means that in the shaded area 1 cannot be present. All right, so similarly for all of the digits you have to fill the Sudoku such that this condition holds. All right, so that's how a Sudoku is solved. So what do you do? So first of all, you for I in the range of length of board 0, that means I in the range of length of first row length, if board of position of 0. Now what does position mean? Position is basically the coordinate of your like the coordinates of your empty cell, right, which is returned from your find empty cell function. So this is where this comes into play. We see that our first value in our array corresponds to our column, right? So position of 0 is basically I, which is basically column, and position of 1 is basically your j value, which is your row value, row index to be more precise. So what it does, if board position 0 comma I equal to your number, so what do? You first loop through each row. So if you see that in any cell of any row my cell value is equal to number, that is the number that you are inserting in that empty cell. So say this is an empty cell, right? Say this is my empty cell for my second row. This is my empty cell and say I'm inserting the value 4 here. And if you find that in this row there is already a 4 present, then that means that this is an invalid entry for my empty cell. So that's what this does. So basically this is row checking. So this first for loop basically checks in each row whether the number that you are entering in your empty cell is present in that row or not. Okay. Similarly, this second for loop does the same thing, but it does it for your columns. So for I in range of length of board, so it goes from first column, second, third, fourth, up till your last column. It checks that if board I comma position of 1, so I basically means so I is your looping variable and position of 1 is your row, right? So it basically checks for your columns. So this is done and this is done. All right, it's a similar kind of logic, so I won't be explaining that. It's the same, like completely similar to your row checking. Now next up, we need to check if our value is present in one of these small tiny boxes, right? So what do? You see that there are 9 such small boxes, right? So what I'm going to do is, let me use a different color first of all. So I'm going to call this index 0, index 1 and index 2 for each of these small boxes. Okay. Similarly, index 0, index 1 and index 2. So this box, first small box, is denoted by 0 comma 0. Similarly, this is 0 comma 1, this is 0 comma 2 and so on. Okay, this will be 2 comma 2. So that's what I'm going to do. So I've defined two variables called box x and box y. So box x is basically your position 1 divided by 3. Since we're effectively compressing our 9 columns into just 3, right? 0, 1 and 2. We had 0 to 8 and we're compressing that into 0, 1 and 2. So I'm dividing the coordinates of my empty cell. Position 1 and position 0, remember, are my coordinates of my empty cell. So so you divided that by 3. Why are we doing this? This is done to find out in which small box our empty cell is lying as of now. Alright. So say I have this. So in this case, your I equal to j equal to will be 4, right? So what do you do? So box x value will be 4 divided by 3, which is equal to 1. Similarly, box y will be 4 divided by 3 equal to 1. So we find that this empty cell is right now currently located in my 1 comma 1 small box. This is my 1 comma 1, right? So this basically finds out in which small box your empty cell is located. Next up, what are we doing is for I in range of box y times multiplied by 3, and it goes from box y multiplied by 3 plus 3. Similarly for j, it goes from box x multiplied by 3 to box x multiplied by 3 plus 3. Why are we doing multiplied by 3 plus 3? Because since we first of all compressed our 9 columns into 3, we are again inverting that operation by decompressing. So basically you first divided by 3, now we are going to multiply it by 3 and add that value to 3. We are going to look in that range to find out the values of my indices for that small box. We need to check. So if I add 1 comma 1, say, then it will check for this cell, 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 this cell. Okay, that's how it works. So then once you find out which small box it's located, you just take your if else condition. So if board of I comma j equal to your number and I comma j not equal to your position, then return false. And if all of this holds, then you return true, which means that the number in this particular board at this position which you have entered is valid. Alright, so that's the valid Sudoku function. Next up, we are solving our Sudoku. This is my final function to make this program run. So what we're going to do is, first of all, you find an empty cell, right? So we call our find empty cell function, which we defined earlier, and assign the value to find. So if not find, so if you've not found any empty cell, what does that mean? That means that there is no empty cell and that your Sudoku has been solved. That means you return true. Else, what do you do? Else, you find your empty cells and assign the values as row comma columns, right? We saw that it returns the position of the empty cell, right? So row comma columns is like that. Next up, what do you do for I in range of 1 comma 10? So you go from 1 comma 10, the range in there. If you call your valid Sudoku function, if valid Sudoku board and the value to be entered is I in this position, and then if that valid Sudoku function returns either true or false. Based on that, if it is true, then the board value at that position is equal to I, because if it's true, that means that it is valid. Then you replace, so you make the board value at that position equal to the number you have entered. If now you call your solve Sudoku recursively, where recursively means in our function definition we're calling that function again. So if solve Sudoku, now you've updated your board by entering a new value that is valid. So you call solve Sudoku again. So this is a recursive process. At the last, when the last cell is filled, this will return true. So if otherwise, now this, so like if this is false, if valid Sudoku and everything is false, what do? You make that cell an empty cell again. So board of row comma column equal to 0 and return false if this does not work. Okay, so that's my function. I hope this video was helpful. So let's just run this code for the sake of it. So this is my board. You can enter any custom board. So I just googled this up. This was a possible Sudoku puzzle. I googled it, I entered it. Now let's see, let's run it. So what you see is that the starting Sudoku board is as follows, where 0 denotes an empty cell, right? You saw I mentioned the hyphens, right? These were the partitions and these were the pipelines, the pipes. All right, and the solution of this is you get a solution instantly. All right, so that's your Sudoku solver function. I hope this video helped. Make sure to like, share, subscribe, and smash the bell icon to stay updated if I drop any more videos. I hope this helped, and I'll see you in the next video, guys. Bye bye.